Okay, I think one more joined. Sandeep. Okay. Hi Sandeep. Hi Lokesh. Okay, let's start. Okay. So today we'll discuss about the completely about AWS introduction. Okay, why we are moving to cloud? What is the advantages of moving to the cloud? What exactly is the cloud computing? What is the various deployment models? Okay, what are the different types of cloud computing? Different cloud, what are the different cloud use cases? Okay, these are the topics that we'll discuss as part of the introduction, so that you will understand the complete basic infrastructure, how the AWS cloud infrastructure would be. Okay. So before going to the cloud, right, first we will understand why actually we are moving to the cloud. First point. Okay. So to understand why, right, first we need to understand we are hosting an application on any server. You might have already aware what exactly is a server and all, right? Why we use the server? We will use a server to install any application, right? For example, you have an Addagutta. Addagutta is a company. Assume that Addagutta is maintaining some softwares and it needs some infrastructure. Okay. Assume Addagutta is an application we are installing on a server to host our website. Like addagutta.in is a website is there, right? To host that website, we need a server of specific configuration. It may be 4 CPU, 8 GB RAM, and some 50 GB storage. The basic with basic configuration. Okay, so we call that as a server. So where we are installing an application is called, we call it as a system or a server. Okay, so where we maintain these servers. For only we hosted a one website. Okay, because Edipol is a very small firm. Okay, assume any bank. Okay, so every bank has to maintain a lot of application, a lot of users will be there, correct? So to maintain that, a number of servers are needed, right? So the place where all servers is maintaining, we call it as a data center, right? So data center is a place where number of servers will be kept and maintained. So in each server, there will be a lot of applications installed, and the end users will use these applications. Assume that any bank, or you can assume any ICICI bank or HDFC bank. Okay, so each company to maintain these servers, right, they will maintain a data center. Okay, so in this data center model, so earlier people, not earlier, in these days also, many companies are using their own data centers. Okay, and most of the companies are already migrated to the cloud, and now there are many companies, they are still planning to migrate to the cloud. So to migrate to the cloud, why actually the companies are migrating to the cloud, why they are planning? So to understand that, right, we need to understand challenges what are the challenges in this data center model. Okay, assume that I have some 50 servers. Currently ICICI Bank is maintaining some 50 servers and they are maintaining their own data center. So what are the challenges? So challenges in the sense, the first challenge would be to maintain a data center, we need a space. For that, we need to pay rent, and 24/7 maintenance is needed with manpower, right? Another main challenge would be scaling the infrastructure. So assume that in this particular data center, I am maintaining 50 servers, 50 physical servers. Okay. So in this, we are maintaining the applications. For example, in future, assume that I need to increase the capacity, because assume that at this point of time, only 1,000 users are using my applications. 50 servers are enough to maintain this 1,000 users, balance the load or different kind of application. Assume that. Now assume that after 2-3 months, it is expected that traffic is increasing to some around 5,000 users. So what I have to do, I have to increase the physical server count. I have to again do the configuration and all this. So what it means, I need to scale, right? I need to scale the infrastructure. I need to, again, I need to install more servers. Okay. So in physical data center model, right? Installing a new server is taking a lot of time. So why? Because it's a physical server, right? We need to place an order request to the vendor, either HP vendor or IBM vendor. Like I need a physical machine. So after that, they'll place a physical machine. Then we need to raise a request to the data center team to connect the cables and all, to connect to the network. After that, again, a data center engineer will take care of arrangements. After that, network engineer will configure the network. Then operating system admin will configure the operating system and server. Then application team will be available to configure the application. So all this process, right, from installing the server to deploying the application is taking a lot of time. Okay, it is a time consuming process to scale an infrastructure when we are maintaining the standard data center approach. Okay, so this is one of the major challenge in the traditional data center model. Okay, and another challenge would be, for example, assume that you have installed the server. Assume a physical memory board. Memory board is failed. Okay, if memory board is failed in physical infrastructure, right? Again, there will be a lot of process in the data center approach. You need to raise a case with the vendor. Vendor will identify whether the part is really faulted or not. Whether it is faulted or not. Then, if it is faulted, we need to raise a request for the new part, and the field engineer will come. Field engineer will replace the part, and then operating system admin will verify whether the part is properly replaced and is properly working fine or not. So, to install the new servers or hardware replacement, we call it as. But if any failures happen, for hardware replacement, right, it is consuming a lot of time in the traditional data center model. So these are the challenges, main challenges we are facing in the traditional data center model approach. That is the reason most of the companies planning to migrate to the cloud. Okay. And also apart from this, right, disaster recovery. Okay, disaster recovery is one of the major challenge. So for example, assume this we are maintaining this data center in Hyderabad. Okay, if something happens to our data center, right, then we need to maintain another data center in Bangalore or somewhere to make sure all the applications, if something happens to this data center, all the applications should run from another data center. Okay, so disaster recovery. So we need to maintain two data centers at a time. Got it? This is again pricing challenge, right? The cost will increase to maintain the data center, to maintain this disaster recovery all the time. So these are all the challenges in the traditional data center model. Okay, so to overcome these traditional challenges, right, then there are multiple companies. Initially Amazon, later different companies like Azure, Google Cloud, Oracle, IBM Cloud. So the different vendors plan to maintain an infrastructure. So hope you understand, right? Now you should be able to understand what are the challenges in the data center approach. Okay. Now we will see, to overcome these challenges, what AWS did initially. So what AWS did initially is AWS created a huge infrastructure. It consists of thousands of servers. Okay. thousands of servers, and they are properly connected with high quality network, and AWS is provided a web interface. Okay, so AWS created a huge data center. In huge data center, the capacity would be very high, and it created a web application, AWS application, and using this application, we are using these resources in the form of AWS services. Okay, so AWS is providing services via a web interface. This is actually called as a cloud. Cloud is nothing but, instead of each company maintaining a different data center, it will be very challenging for the each company. So what AWS did is created a huge infrastructure. Now, ICICI Bank said, I need 50 servers. Then immediately within a few minutes, using this web interface, you can launch you can launch 50 servers. Assume that for business one company need 50 servers. Assume that some other company need 100, some other company need 200. So within a span of minutes, according to the configuration, okay, business 1, business 2, business 3, according to the configuration, you can create n number of servers. You can create the infrastructure, you can create the networking. Via, there will be, AWS is providing different types of services. You can all these services via a web interface. Using this web interface, anyone can launch any service. Like to create a server, we are using EC2 service. Okay, to establish, if you want to use a DNS service, we are using Route 53 service. So using Route 53, we will configure the DNS. If you want a storage, we are using a S3. S3 is the storage bucket. We are using simple storage service. Using this, we can create a storage via web interface. So all this, see, everything AWS is maintaining is everything is implemented in a logical way. Means the hardware, right? Assume that there is one physical hardware, with high configuration. It is logically partitioned in such a way that whatever the configuration we are requesting, right? If I want 8 CPUs, 16 GB and 50 storage, 16 GB memory and 50 GB storage, if you are requesting, right? It is configured in such a way that using this configuration, a virtual machine or EC2 instance will be launched within minutes. So everything is done logical at the hardware level also. Even the networking interfaces, virtual networks we can create. Okay, completely the physical hardware is divided using hypervisors. Multiple VMs can be created in a one physical hardware. So everything they have planned with using a very good technologies. Everything, the physical hardware, the physical data center is made completely logical, so that we can use the different AWS services, and you can use different AWS services in an effective way. Using the web application, just using your laptop, you can launch, you can create n number of servers, you can install n number of applications, you can run the complete business using a single account. Okay, so this is called as cloud. Okay, so cloud, what is cloud computing then? Cloud computing is nothing but on-demand usage of resources, on-demand usage of AWS resources like CPU, memory, storage, and other IT resources. Other means like it may be networking, firewall, security, storage. So everything is considered as a resource. Everything is considered as a service. So cloud computing is nothing but on-demand usage of IT resources like CPU, memory, storage, and all is called as cloud computing. On-demand means whenever you want it. If you want to launch an EC2 instance of this specific configuration, we can launch it within a minute. If you want to delete the instance, you can delete the instance. If you want to increase the memory of a particular server, you can increase on demand. Whenever you need it, you can increase. Whenever you don't want to do it, you can reduce it. So this is how the flexibility is available in the cloud approach compared to the data center approach. Okay, this is the reason why people are migrating to the cloud. Okay, cloud is nothing but many vendors created a huge infrastructure, completely made it logical. Using a web interfaces, we can use the services provided by the respective cloud. Either it may be AWS, Azure, any cloud, on demand. Whenever you need it, you can create it. Okay, this is all cloud computing is nothing but on-demand usage of resources and all. Clear? Any doubts till here? Now you should be understand what are the challenges in the traditional IT approach and what exactly is cloud, what is made by cloud computing. Clear? Any doubts till here? Sandeep, Lokesh?
No, I'm good. I understand.
Yeah, okay, yeah, thanks. Sandeep, am I audible? I think you're on mute, Sandeep, if you're speaking. Okay, that's fine. Okay, let's move to the next topic, deployment models of cloud. Deployment models of cloud in the sense, there are different types of cloud. Public, private, hybrid. Okay, public, private, and hybrid. Public cloud means AWS is providing an infrastructure, right? Not only, for example, a person or a company, C1, requested 50 servers via AWS. Okay, so AWS is a public platform, means anyone, any company can request any number of servers. In these servers, AWS will provide the servers to the respective company. So just providing the requirement, like providing the number of instances, number of EC2 instance, all this, right? This is completely AWS is a public, it is in a public domain, right? This is called as public, different deployment models, right? One is public, private, and hybrid. Public means anyone can use it, means it can be shared one. Okay, in the AWS is providing different services, out of which, according to the company, different company requirements, you can use this number of servers according to the requirement. AWS will provide according from the shared infrastructure. Okay, so it is not going to provide you some. There are different deployment models in AWS also that we will discuss in the future. Just to understand, right, what is a public deployment models? It's like, as AWS is a global infrastructure and it is in the public domain. Okay, according to the customer requirements, they will provide the resources. This is called, we call it as a, it is publicly available. That is called as public cloud. What is a private cloud? Private cloud in the sense, we have a data centers, right? Every company is maintaining the data centers. They want to maintain everything within the data center. This is called data center. This is a AWS public domain, public cloud, data center. Okay, so all the resources, ICICI Bank currently is using traditional data center method only. So they don't want to share the resources with anyone, any other company. Okay, this is on-prem model or virtualization model also, we can say. Okay, if company is maintaining everything in a private, they don't want to share the resources with anyone. Okay, those type of deployment models, we call it as a private cloud. And public is, it can be, these resources can be shareable with different customers. Okay, so in private cloud, private deployment model of cloud means completely it's a data center approach where no other customers will share this infrastructure. Only one company or ICICI Bank, assume now for now, to get the better understanding, ICICI using 50 servers in a traditional data center model. This is they want, because it is a high sensitive applications, finance applications. They don't want to share it with any other customers. They don't want to put it in a public domain. So complete network level layering, everything would be dedicated to ICICI Bank, those applications only. So those kind of deployments, we call it as a private. Public means there with low risk applications are there. So assume that same ICICI Bank have some only user related applications. Those are not highly financial critical applications. So they can host on a public domain also. Assume that 50 servers are in a private cloud. ICICI Bank is maintaining another 50 servers in a public domain. If any company maintains, for example, any company maintaining 50 servers using both private cloud and public cloud in this combination, right? If any company is maintaining the servers in this combination, that is called as hybrid cloud. Means a company having both on-prem infrastructure and cloud infrastructure. On-prem infrastructure means private, they are using the private cloud only for high critical applications, and for less normal applications they are using a public cloud. Means now we can say that this ICICI Bank is a hybrid model deployment. They are using a hybrid model cloud. Okay, because it's maintaining servers both in a private cloud, both in a public cloud. So this is how we can define a different deployment models like public cloud, private cloud, and a hybrid cloud. Clear?
Yeah, it's clear.
Okay. Okay. Now we'll discuss what are the different characteristics of cloud computing. Characteristics means in the cloud, assume that you have an application. Okay. Now your application, assume that Amazon application is there. In AWS, assume that you have created 3 servers and you have installed your application. Assume that application is Edupoli. Edupoli is the application you have installed. Okay. Now, currently, 1,000 users are using this application. Assume that in the next week, there are 5,000 users are, you estimate that because of some offers, assume it is an e-commerce application, right? In that e-commerce application, if in the next week, assume that the number of users may increase. So in a cloud, right, there is a feasibility that you can increase the number of VMs on the fly. Within no time, you can configure in such a way that by next week, you can increase this within a few minutes, right, to support this number of users. This is characteristic is called as scalability. Okay, scalability means you can increase the resources depending upon the requirement. After 2 weeks, assume that again the number of users are reducing to 1,000. Then you can now from 4 to 8, you can increase. Now again you can reduce it to the 4. So the main in cloud environment, this is the main advantage. Whereas in data center approach, this is the main disadvantage. You cannot increase the physical servers. You cannot increase the servers on the fly. But you can do it in the cloud environment within a few span of time. That feature we call as scalability. Okay, in scalability also there is different two types we can discuss, specifically mention. One is horizontal scalability, and the one is vertical scalability. Horizontal scalability means, this is a correct example of horizontal scalability. Means initially we have 4 VMs, 4 EC2 instances. When the number of users increased, 4 VMs, 4 EC2 instances of specific configuration, like each 4 CPU, 8 GB memory. Okay, with this configuration, there are 4 servers initially. Now it is increased to 8 on week 2. After week 3, the number of users reduced. Again, you will have reduced to 4. Assume that each server having this much configuration. So you are increasing the count of the servers and decreasing the count. This is called as horizontal scalability. Horizontal scalability. Okay. Then what is meant by vertical scalability? Sometimes, depending upon the application, currently this is the configuration you are using for a respective server. Okay. Now, if assume that the number of users increased from 1000 to 1500, instead of launching a new instance, we can increase the configuration of the existing EC2 instance from 4 CPU to 8 CPU, 8 GB memory to 16 GB memory. So we can also do this on the fly, on demand. Okay, this is called as
Am I
vertical.
audible?
Yes, yes.
Sorry. Actually, that mic was disabled, so that's why I couldn't speak earlier.
No problem. You are listening, right?
Yes. 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 Yes.
Okay. Just let me know if you have any questions.
Okay.
Okay. Now we are discussing about the scalability features of cloud computing. Okay. The main disadvantages in the data center approach is we cannot scale the infrastructure. But whereas in case of cloud approach, the scalability is it is a main important feature, because we can increase the resources at any point of time within a few minutes. We can decrease also. Example, just consider a big billion day sale. Okay, assume that how do you think that in the back end how the servers are supporting? Assume that in the big billion day sale, Flipkart, the number of users in those 4 days will increase like anything. So in the back end, what they'll do, they'll configure in such a way that if the number of users increases, the number of instances will increase like anything. Once the sale is completed, it will reduce like this only from 4 to 8, 8 to 4. So this is the main important feature in the cloud model, scalability. Okay, it may be horizontal or vertical scalability. Horizontal means increasing the number of instances. Vertical means increasing the size of the instance. Okay, we'll discuss more on this when we discuss the EC2 service. Okay, you will get much clarity how the things will happen. With the live example, we can see it. How to increase, how the instances can be increased, how the instances can be decreased with a simple option. Okay. And main important another feature is on demand. We already discussed this. On demand means whenever we need it, we'll get it. If I want to install, create 5 instances, you can. 10 instances, you can. Within a single click, we can create n number of instances. If you want to increase or decrease anything. Okay, this is one of the main important feature of cloud computing. Okay, we can say this. Another important feature, one is scalability, we discussed. One is on-demand self-service. On-demand self-service means, on-demand means whenever we need it. Self-service means you can only do it from the web portal. Okay, I'll list down on-demand self-service is one of the important feature. Another one is scalability. These are the main two important features. Okay. Another one is resource pooling. Why people are moving to cloud? The main, see, every company, what they'll think about the costing, right? If you maintain a separate data center approach, the pricing will be very high. The maintenance will be very high. You need to maintain a separate manpower to maintain the data center. Okay. But whereas in case of AWS, right, or any other cloud provider, what they are doing, they are creating a huge infrastructure and they are sharing the resources. This is called as, we call it as a resource pooling, or we can call as multi-tenancy. Multi-tenancy means multiple companies using the same AWS infrastructure. So what AWS is using it, they are sharing the resources. If I want 50 servers, company C1 wants 50 servers, they are giving. And company C2 wants 100. Company C3 wants another 30 servers. Like that, if there are multiple small companies, they are using the shared resources. That's why we call it as a resource pooling. Multi-tenancy means multiple companies are using the cloud, same cloud. So when they are using the shared infrastructure, of course, there will be no compromise in the security when AWS is providing. Each company means they completely, these are isolated at the network level. There won't be any overlapping between the networks. The security part, the maintenance part, everything will be taken care of by AWS. So the customers may not worry about the any issues at the data center level. Either it will be any hardware, physical damage, anything. It's responsibility of AWS to provide the high availability, to provide the security. Everything will be taken care of AWS. So companies no need to worry about the maintaining the infrastructure. They can simply concentrate on the business and the applications to configure. Okay, so because of this resource pooling and multi-tenancy approach, what's happening? The AWS is giving the better prices to the customers because they are sharing the infrastructure with very good security. They are sharing the resources. Obviously, what happens when we share the resources, the price will reduce, right? If you go to from Uppal to JNTU, if you book a cab, it will be around 700, right? If you book a shared cab, it will be around 150, right? Why? You are sharing the resources. So this is the same model AWS is using. That's the reason most of the data centers are migrating to the cloud. They are providing better service using AWS services. Using better services, they are providing very good services using this, and also they are giving better prices. So what's happening? Companies are moving to cloud because they don't want to maintain they don't want any more infrastructure level headache, and prices are going to reduce comparatively. So because of this, many companies are moving to the, because of these features. Okay, there are any price, okay, challenging price cloud providers are providing. So why only AWS? There are many cloud providers, right? Azure, GCP, OCI, right? So initially, AWS entered the market and occupied most of the market. So when the number of companies started using the AWS services, right, they can give the better prices. That is the only reason most of the companies moving to the AWS. AWS is providing more number of services, around 400 plus services AWS is providing. Data analytics, artificial intelligence services, software as a services, many things. Many services AWS is providing. Along with that, they are providing good prices because the number of users using the AWS cloud is more. When the number of people using the specific service more, right, what happens automatically? They can give the better prices, right? With a simple example, you can say, if the same product, right, if number of persons purchasing the same product is increased, automatically you can give the better prices compared to other cloud providers, right? So that is the reason most of the people preferring AWS. Of course, it depends upon their own challenges or own requirements. Depending upon the company requirements, they are choosing Azure GCP also. But market leader is currently AWS, next Azure, and later comes the GCP, IBM, Oracle, these. Okay, so these are the main important characteristics or features. This is become the advantage for companies to move to the clouds. Okay, this is, we can say, now you should be able to get a clear understanding of what are the challenges in the traditional data center approach, what is cloud computing, what are the different deployment models like public, private, hybrid, what are the features of cloud computing. You should be clear with that. Any questions still here?
No, I understand it. Don't have any.
Okay. Yeah. Okay. Next, we'll discuss what are the different types of cloud computing. Different types of cloud computing. Now here, you need to understand here. AWS is providing, or not AWS, any cloud provider providing the different ways, like infrastructure as a service. These are very, very important, these terminologies. IaaS, PaaS, SaaS, infrastructure as a service, PaaS as a service, software as a service. Okay, what it means is these are the main different types of services any cloud provider is providing to the customers. What exactly is infrastructure as a service? Okay, now assume that you have an application. Customer came with an application at poly.in. This is the website I have prepared. I have to install on a particular server. You can request AWS, give me only bare metal server, means give me EC2 instance of 4 CPUs, 8 GB RAM, and 20 GB storage. This is enough for me. Give just this server with Linux operating system. Then I will install my application. I have my code developed in JavaScript. Okay, I will install the required softwares on this and I will install my application. So what AWS is providing here? AWS is providing only the plain server, giving the only plain infrastructure. So AWS is giving only this one kind of service. This is called as infrastructure. So AWS is giving the plain. So what Edupoly application is, they want, the requirement is only give me the plain server with specific configuration. I will install the application myself. You don't need to do anything. So when the AWS is providing one type of service, that is called as, they are providing the infrastructure to my application. So these kind of services is called as IaaS. EC2 is an example of IaaS service. There are different kind of IaaS services that AWS is providing. One of which is EC2, Elastic Compute Cloud. Assume now I have developed the application in a much bigger way. Number of users increasing. Now I have to use database also in my application to store the data. I need a structured format of storing the data. That's why I used along with my application. Means I have developed the application using JavaScript. Now I want MySQL database also. To install my application, I need these two technologies. So when you are using these two technologies, initially only JavaScript is present for your application. Now for your application, you are using two technologies. AWS is also providing a ready-made platform as a service. Means AWS can give it directly using RDS is a service, relational database service. Okay, AWS has a one service type of relational database service, which if you launch RDS instance, means with respect to your database, whatever the database, either MySQL or MS SQL or Oracle or anything, Postgres, any database, directly you can launch the database using RDS service. Means once you launch an RDS service with MySQL, right? Then directly you are getting an instance with MySQL installed by default. You need to install only my JavaScript. Just you need to install this. So they are giving the platform also ready. Amazon is using RDS service. They are setting a platform for you with MySQL already installed. So these kind of services we called as platform as a service. Initial case, they provided the plain server because you don't need the database. You will install the application. But in this case, your application need MySQL technology, MySQL database also. So there is an RDS service in AWS. If you launch this RDS service, you can directly launch the MySQL RDS instance by default. If there will be using RDS, you can launch different databases instances. As my requirement is MySQL, you can directly launch MySQL RDS instance. So you are setting the AWS is now what is doing, setting the platform ready. After that, you can install your JavaScript application code in the RDS instance. Your application will run properly. So here AWS is providing, the platform also is getting ready using this RDS service. Okay, these kind of services is called as platform as a service. So RDS is one of the example of PaaS service. Then what is software as a service? Means AWS is providing one service. Assume there is a recognition is one of the software, recognition, AI related software. So AWS, if you launch this recognition service, right, the application itself is completely ready. You don't need to deploy application also. In the first case, you have deployed the application. In the second case, the DB instance is ready. Only you installed application, DB platform level, it is ready. Now your application, database, whatever you need, everything will be get ready. Just you need to start using it directly. No need to install any application. Those kind of services are called as software as a service. Example, Gmail. Gmail is also a software as a service. Are you installing anything? No, right? Just you are giving gmail.com. That's it. In the backend, what's happening? It is launching a service directly in the Google Cloud. Gmail. So it is a software as a service example. So these are the different types of service. If only a plain server is providing to install application, that is called as infrastructure as a service. If they are giving to install our application, if you are giving a proper platform like any database installed, there are many other examples. This is one, RDS is one of the example. Okay, in the same way, if your application itself is properly installed and they are providing directly the service, any cloud provider, those are called as software as a service. Okay, there are examples software as a service. Dropbox. Dropbox also is that is also software as a service. Okay, recognition. AWS recognition is a tool. That is also. So these are the different types of cloud computing, we can say. IaaS, PaaS. These terminologies are important. If you go to any cloud provider, if you understand what is IaaS, PaaS, and SaaS, then it will be very good. Coming to different,
I
yeah,
have one question.
yes,
Like, can you give me any one company example, like who is using IaaS, like normally?
anyone. It can be any company, right?
Mhm.
I have uh, currently my application. It's not
Okay.
like any company. If you,
Mhm.
according to your requirement, if your application requirement is to launch only EC2 instance, I don't want any other software. I have my application. I will install Java. After installing Java, I will write a code. My application is completely Java based. So give me one server. They will provide a server. You will install Java software. After that, you will run the application. So many companies, depending on the company requirement, depending on the application requirement, they will launch a respective service. Any company can use, if the company needs a database service, they will use a platform as a service. If they use normal plain server, they will use customized applications would be there. Okay, customized application means you are writing your own application. For that, company cannot provide the platform, right? If your application uses any standard services like database service or Nginx, Tomcat, Apache, these are the standard services, right? For that, you can launch a respective platform as a service with respect to database. I'm speaking. Okay, there won't be any like standard example which company is using this. It depends on it. Okay, for example, complete AWS in Netflix is completely running on AWS, not from the starting.
I I think Netflix is a SaaS, I guess, right?
Yeah, software as a service. Because there are multiple services Netflix is using. It's not like completely SaaS. Okay, depends upon if you are directly clicking on a movie, right? When you open a Netflix, if you're opening a movie means backend it is configured as a software as a service. Okay, there are some different applications in the. For example, when you are logging into Netflix, right, you will get a web application. You need to create your account. For that specific application, software as a service is not needed. Okay, that application will be hosted on a simple EC2 instance. Okay, so depending upon the requirement of their respective applications, the customers will use it. Okay, in the same Netflix company, as I said, right, Gmail. Gmail is a software as a service. Okay, RDS. If you for example, if Sensex is there, right? Daily you will do trading, right? Many people. Okay, so many people they are using the trading, right? You are using. You can use any ICICI bank application, anything for trading. Multiple transactions will happen at the trading level, right? All the data will be stored in the directly at the database, right? So at those scenarios, they will use a platform as a service. It's completely based upon the requirement. Based upon the requirement only, they will choose what type of service they want. Clear? Still any doubt?
Yes. Yeah. No. No. Clear. I'm clear.
Yeah, okay, good. So these are the different types of use cases like Netflix, even McDonald's is used by AWS support and maintenance. Okay, so these are different types of cloud use cases. Okay, so this is all the basic introduction to the cloud. Okay, so from the next class onwards, we will see, we'll discuss about the different types of services. So main important services that we are going to cover is EC2, storage, for storage S3, for databases RDS service, okay, and for content delivery network we will use CloudFront, okay, and S3, so simple storage service, and load balancers, ELB, application load balancer, and network load balancer we'll discuss, okay, and for monitoring everything there is a service called CloudWatch, okay, and we will discuss more about the network level architectures, how to design the network architectures, okay, and we'll discuss about the Route 53, the DNS service providing with applications, and we'll discuss about the virtual private cloud, VPC, networking, that is the most important, okay, and there are some other services that are most widely used and important, we'll discuss in this course, okay. So the classes will be every Monday, Wednesday, Friday, and Saturday, 8:30 to 10. Okay. Every month, just remember the timings: Monday, Wednesday, Friday, and Saturday. As I am working, these timings are flexible for me. Okay, and also you will get time to learn the topic, practice the topic also. You'll get some enough time. If the class is completed Monday, you'll get some time on, as you people are working, right? You can practice on Tuesday. Again, Wednesday will be class. You can practice for Thursday and Friday. Anyway, Saturday is weekend. You can practice. So this will the flexibility designed in such a way that it will be flexible for you people and for me also. Okay, this is how we design the classes.
It is online and offline. Both are available, right?
Yes, yes, both are available. You can directly come to office also.
Okay. So the timing will be fixed, right? Because you cannot change the time, right? So
Timing is fixed. 8:30 to 10 a.m. Monday,
oh,
Wednesday, Friday, Saturday. Yeah.
yeah, Monday, Wednesday, Friday, Saturday.
Yes, you can come
Okay,
back.
okay,
Okay.
okay, okay. And what is like duration? Like how many months it will take to complete the course?
See, for AWS completely, we are taking, it will be like 30 hours. 30 hours it
30.
will take to
Okay,
completely to prepare for the certificate, associate level certification. You can do it
okay,
if you prepare properly.
okay.
Okay, 30 hours would be very much fine
Hmm.
by AWS.
Okay.
And continuation will be DevOps that will take another 25 to 30 hours.
With only DevOps, so can we get the job, sir? Normally, I'm asking. With only the AWS?
With only AWS, you have to do the certification. But see, the now the market is very competitive, right?
Yeah, yeah,
So
yeah.
learning with one technology is quite a bit difficult. Okay,
Mm.
so better to have a good amount of knowledge on different technologies, and you should be expertise at one point, one or two technologies. That would be very much helpful to get the job easy.
Okay.
So,
Actually, currently I'm in testing background, so I wanted to upgrade myself. So that's why.
good thought, good thought. Yeah, in that scenarios, better DevOps is also, see, whatever the technology background is there, the completely market is evolving into DevOps, right?
Okay.
Yeah, so learning the DevOps and AWS is the right combination to upgrade and good and better position. Okay,
Okay.
the
Okay.
market is evaluating already.
Okay.
Okay.